Okay, we want to work on this problem from section 3.4. This is finding the derivative. Notice that the problem does say use technology to find this derivative. So that means use the calculator. So the TI-84 calculator actually does have this capability, at least graphically, so I'm going to just go through on how to do that. So the first thing you want to do is enter the function. So we'll do that here. We press y equals enter the function. So we put negative 2x squared plus 11x and enter, and then you can answer these questions actually on the graph, but we have to notice the x values that we're looking at here. 2, 17, and negative 3. So I'm going to have to change the window so that I can see these values. So I'm going to, since the smallest x value I have is negative 3, I'm going to go down to negative 5. And I'm going to do the 17 later. So right now I'm just going to look at the minus 3 and the 2. So I'm going to go from negative 2 to 5 on the x values. And let's just take a look at what the graph looks like for those x values. Okay, so we find we can't quite see up here on the top, so that's an indication that we need to change our window. I'm going to change the y max value up to 20 instead of 10, and hopefully we'll be able to see more of the graph. Okay, so that looks pretty good. In fact, I'm going to change one more thing. See how all these little tick marks are here? That just is an indication that 1 is probably too small of a number for the scale. I'm going to use 4 instead. So one more time, we'll graph it. Okay, so I think, let's see, at negative 3 we might have a bit of a problem too, because negative 3 is down here. I can't really see the graph, so I'm going to have to change the minimum value as well. Let's go down to negative, let's try negative 30, see what that looks like. Not quite. Let's change it just a little bit more. Let's go to negative 50. And since I'm doing that, I'm going to have to change the scale again. Let's just go to 10 on that. Okay, so I think that's going to be enough for us to see what we need to see, at least for the 2 and the negative 3 part of it. We'll do the 17 in a minute here. Another way that you can tell like what an appropriate y value would be is if you actually just take these numbers and plug them into the function. You see what the output is. That'll give you an idea of how large you should make y max or y min. Anyway, let's go ahead and find the derivative. We'll start with the f prime of 2. So the way that we're going to do this, we're going to go to calc. And if you notice on there, you've got the sixth one, dy dx. That is actually notation to find the derivative. So I'm going to hit that. And we want to find this at a particular x value at x equals 2. So if I go over here to 2 and just press enter, and you see what it says, dy dx is equal to 3. Okay, so that's telling us the answer. That's what we're going to put in here on this part of our answer. And then you would just do this again for, let's go ahead and do negative 3. So let's calculate the derivative at negative 3. Go to 6, enter minus 3 for our x value, and then it tells us what the derivative is, 23. Now remember what the derivative is. Hopefully you've been reading about it. It's the slope of the tangent line. So basically if I draw a tangent line that just barely glances the function at negative 3, it's going to be pretty steep. That's what that 23 means. The slope of 23 means like if you were to draw that line, you'd go 23 units up, 1 unit right, 23 units up, 1 unit right. That would be the slope of the tangent line. Finally, let's do 17. In order to see like what our y value should be there at 17, what you can do, you can just plug 17 into that function. So if you want to do that, you can just maybe go back to the home screen, quit out of here, and just plug in 17 and see what we get for our output. So negative 2 times 17 squared plus 11 times 17, and we get a value of negative 391. So that's going to tell us that when we want to actually do this for our window, remember that's x equals 17, we'll do a window that's kind of around 17. Maybe we'll go from like 0 to 20, and I'll go ahead and change that to 2. And what was it, like negative 300 and something. So let's go, the y min value will go negative 350, and the y max value will go, I don't know, negative 100 or something like that, just enough to really see the area that we're really interested in. And I'll go ahead and change this to 50, and then we can graph it. We should hopefully see the part of the graph that we're looking for. So when x is equal to 17, I believe that's 20, 19, 18. So 17 will be right here. Let's go ahead and find that derivative now. So we'll go to calc. We'll press 6 again. And now we'll put in 17. Enter. The derivative is negative 57. So that answers the third part. Okay, so this is the way, whenever it says use technology, this is what they're talking about to find that derivative. Okay, the TI-89 calculator will actually do this without having to graph it, and that's kind of why we actually ban the TI-89 from any calculus class, because it'll just do all this stuff for people. For the TI-84, you kind of have to do a little bit of extra here, and really all it's doing is just showing the slope of the tangent line at a particular x value. Anyway, it's useful for this particular question, so that's the way that we want to approach a question like this.